Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We are from group 2. First of all, let me introduce. My name is Santi Sri Herlina, who will serve as moderator today. The member of my group are Rainadi Gabriel Silalahi and Shakila Azaki Fiandi. We will discuss about speech organ. The one who will explain first is myself. Speech organ brain is mostly involved in cognitive working, thus it brings the origin of language in an abstract form. This abstract form is then brought forward in concrete form through different body organs, which receive message from brain. These body organs give rise to spoken language, which was once in form of neurons or signals in mind. Such organs are known as speech organs. All of the sounds we produce are because the muscle contraction or expansion, the muscles in the chest that we use for breathing produce the flow of air that is needed for almost all speech sounds. Muscles in the larynx produce many different modifications in the flow of air from the chest to the mouth. After passing through the larynx, the air goes through what we call the vocal tract, which ends at the mouth and nostrils. Here, the air from the lungs escapes into the atmosphere. We have a large and complex set of muscles that can produce change in the shape of the vocal tract. And in order to learn how the sounds of speech are produced, it is necessary to become familiar with the different parts of the vocal tract. These different parts are called articulators, and the study of them is called articulatory phonetics. Speech organs that belong to articulatory systems: lips, teeth, tongue, uvula, glottis, alveolar ridge, hard palate, and velum or soft palate. Lips form different shapes, such as an oval, and movements in order to make different sounds. Sounds can be formed by using the teeth or to shape the lips, in combination with the tongue, or to block air from escaping the mouth. The tongue moves throughout the mouth and with many of the other organs, as well as making shapes like the lips, in the order to formulate speech. The uvula is used to make guttural sounds. It helps to make nasal consonants by stopping air from moving through the nose. The glottis is used in controlling the vibration made by the vocal cords in order to make different sounds. The alveolar ridge helps us to make different sounds, known as alveolar sounds. The tongue touches the ridge found on this organ. Heart plate, like the alveolar ridge, is an organ of speech where the tongue touches and taps the palate when articulating speech. The movable velum can retract and elevate in order to separate the mouth from the nasal cavity, helping to make speech less nasally. When the tongue hits the velum, it also makes a special sound called a velar consonant. For the next is manner of articulation. The first is stop or plosives. The manner of articulation of stop or plosive sounds is produced by complete stopping of the airstream and let it go abruptly. The second is fricatives. The manner of articulation of stop or plosive sounds is produced by almost blocking the airstream and pushing the air through a narrow opening. By pushing the air through, a type of friction is produced, and the produced sound are called fricatives. If you, for example, put your palm in front of your mouth when producing fricative sounds, you feel the stream of air being pushed out. The third is affricate. The manner of articulation of affricate sounds is produced by the brief stopping followed by an abstracted release which results in some friction. Fourth is nasals. The manner of articulation of nasal sounds is produced by lowering the velum and following the airstream to flow out through the nose to produce nasal sounds. Next is place of articulation. First is bilabials. Bilabials are produced through upper and lower lips. Second is labiodentals. Labiodental sounds are produced through the upper teeth and the lower lip. The third is dental. Dental sound is produced by placing the tongue tip behind the upper front teeth. Fourth, interdental or intradental is sometimes applied to describe a manner of pronunciation with the tongue tip between the upper and lower teeth. 5 is alveolars. Alveolar sounds is produced through the front part of the tongue placed and on the alveolar ridge. 6 at alveopalatals. These are produced by placing the tongue at the very front of the palate, which is near the alveolar ridge. The 7 is velars. The production of velar sound is done by placing the back of the tongue against the velum. 8. Glottal. This is produced without the active of the tongue and other parts of the mouth. This is sounds is produced the glottis, a space between the vocal cords and the larynx. The next is lips. Lips include upper lip and lower lip. They serve for creating different sounds, mainly the labial and bilabial. Example: p, b, and w. Labiodental consonant sounds, example f and f, round to produce the lip shape from vowels like u, and thus create an important part of the speech apparatus. Teeth. The small whitish structure found in jaws in front of mouth. Immediately after the lips are teeth. They are responsible for creating sounds, mainly the labiodental. Example: f and f. And linguodental, example ch, da, and j. Alveolar ridge. Alveolar ridge is basically hard ridge behind the upper front teeth. It is between the roof of mouth and the upper teeth. You can feel its shape with your tongue. Its surface is really much ruder than it feels, and is covered with the literature for the sound S. Air from the lungs passes continuously through the mouth, but the tongue is raised sufficiently close to the alveolar ridge to cause friction as the partially blocks the air that passes. Moreover, sounds made with the tongue touching here, such as the and the, are called alveolar. Hard palate. Hard palate is a thin horizontal bony plate of the skull, located in the roof of the mouth. It is smooth, curved surface can feel with the tongue. The interaction between the tongue and the hard palate is essential in the formation of certain speech sounds, notably t, d, and j.
5. Velum or soft palate. The velum or soft palate is in a position that allows air to pass through the nose and through the mouth. Often in speech, it is raised so that air can escape through the nose. Its main function is to separate the nasal cavity from oral cavity in order to produce the oral speech sound. If the separation is incomplete, air escapes through the nose during speech, and the speech is perceived as hypernasal. The other important thing about the velum is that it is one of the articulatures that can be touched by the tongue. When we make the sound and the tongue is in contact with the lower side of the velum, and we call this velar consonants. 6. Uvula. The hanging boss full name is the palatine uvula, referring to its location on your soft lid. It functions in tandem with the back of the throat, the plate, and air coming up from the lungs to create a number of guttural and other sounds. In many languages, it closes to prevent air escaping through the nose when making some sounds. 7. Glottis. The combination of vocal folds and speech in between the folds is known as glottis. As the vocal voice vibrate, the resulting vibration produces a buzzing quality to the speech called voice or voicing or pronunciation. Sound production involving only the glottis is called glottal. Example is the sound. The vibration produced is an essential component of voiced consonants as well as vowels. If the vocal folds are drawn apart, air flows between them causing no vibration as in the production of voiceless consonants. The glottis is also important in the philosophy maneuver. For the example, one voiced consonants include there are sh, j, b, d, g, and last w. For the second example is the voiceless consonants include s, sh, sh, s, t, k, and last m. H, tone. The tone is a very important articulator and it can be moved into many different places and different shapes. Its movement in oral cavity plays important part in production of almost every speech sound. Usually, it is divided into different parts. For the example, there are type, blade, front, back, and the last root. Besides these articulatory organs, other major parts of the body also play an important role in the production of speech sounds, which are following. 1. Palate. Palate is the roof of the oral cavity that separates the oral cavity from the nasal cavity. Consists of the hard palate and soft palate. 2. Nasal cavity is either of the two cavities lying between the floor of the cranium and the roof of the mouth and extending from the face to the pharynx. 3. Alveolar ridge. Alveolar ridge is a ridge that forms the borders of the upper and lower jaws and contains the sockets of the teeth. 4. Oral cavity. Oral cavity is the opening tract with food is taken in and vocalizations merge. 5. Velum. Velum is a muscular flap that closes off the nasopharynx during swallowing or speaking. 6. Uvula. Uvula is the pendant flesh lobe in the middle of the posterior border of the soft blade. 7. Tunch back. Tunch back is the back of tunch. 8. Pharyngeal cavity. Pharyngeal cavity is the cavity of the pharynx that consists of a part continuous anteriorly with the nasal cavity by way of the nasopharynx, a part opening into the oral cavity by way of the isthmus of the fauces, and a part continuous posteriorly with the esophagus and opening into the larynx by way of the epiglottis. 9. Epiglottis. Epiglottis is a leaf-shaped flap in the throat that prevents food from entering the windpipe and the lungs. It stays open during breathing, allowing air into the larynx. The next example is touch blade, touch tip, lips, nose, teeth, vocal folds, glottis, and the last larynx or voice box. Okay, thank you for attention.
The lungs. The function of all the above mentioned body part is to produce speech sound, and speech requires some sort of air source. We produce a majority of speech sound by forcing air upwards from the lungs, an action that is used in normal breathing. But it is necessary that in order to produce a speech sound, the outward moving airstream must be modified by the manipulation of the larynx and the articulators in the oral and nasal cavities. The way in which the airstream is modified is the focus on this module. Normally, speech is created with pulmonary pressure provided by the lungs that generates sound by the phonation through the glottis in the larynx, then is modified by the vocal tract into different vowels and consonants. However, the production can occur without use of the lungs and glottis in laryngeal speech by the using the upper part of the vocal tract. An example of such laryngeal speech in Donald Duck talk. The most important function of the lungs, which is relevant to speech production, is respiration, and it is responsible for the movement of the air. Lungs are controlled by a set of muscles which make them expand and contract alternately so that the air from outside is drawn in and pushed out alternatively. When the air is pushed out of the lungs, it passes through the windpipe and the trachea, which has at its top of the larynx. The larynx, or usually called the voice box, containing the vocal folds and the glottis. The larynx are more commonly known as the voice box or the Adam's apple, when crucial on the production differentiation in speech sound. The larynx is located at exactly the point where the throat divides between the trachea or the windpipe, which leads to the lungs and the esophagus, the tube that carries food and ordering to the stomach. Over the larynx is a flap called epiglottis that closes off the trachea when we swallow. When the epiglottis is folded back out of the way, the part of the larynx that are involved in speech production can be seen. The most important the larynx are commonly called voice box or the glottis is the passageway for the air between the pharynx above and the trachea below, and it extends from the fourth and the sixth vertebral levels. The larynx is often divided into three sections, which is sublarynx, larynx, and supralarynx. It is formed by nine cartilages that are connected to each other by muscles and ligaments. The larynx play an essential role in a human speech. During the sound production, the vocal cords are close together and vibrate as air expelled from the lungs passes between them. The false vocal folds have no role in sound production, but help close of larynx when food is swallowed. The vocal folds. There are two thin sheets of the tissue that stretch in a V-shaped fashion from the front to the back of the larynx. These are called the vocal folds. You'll often hear of vocal cords, which doesn't accurately convey the way the muscle works. The space between the vocal folds and the space between the vocal folds is known as the glottis. The vocal folds can be positioned different ways to create speech sound. Air passes through the vocal folds. If the vocal folds are open and air passes unobstructed, the vocal folds do not vibrate. Sound produced this way are called voiceless. But if the vocal folds are held together and tense and air doesn't pass unobstructed, the sound produced this way are called voice. Briefly, the vocal folds are folds of tissue located in the larynx or voice box that have three important functions. One is to protect the airway from choking on material in the throat. And second is to regulate the flow of air into our lung, the production of sound used for speech, and lastly, the front of two-thirds of the vocal fold is made up of muscle covered in thin layer called mucosa. The back of one-third is made up of the cartilage is called vocal process, which is also covered in by mucosa. When we speak muscles in the larynx and bring the vocal folds together, as the air rushes from our lungs out through the larynx, the front portion of the vocal cord are vibrates and producing the sound. The upper portion of our throat then modifies this sound to produce speech. The true vocal folds represent the chief of mechanism of the larynx in its big function as a valve for opening the airway, for breathing, and close to during swallowing. The focal folds are supported by the thyroarytenoid ligaments, which extend from the focal process of the arytenoid cartilages forward to the inside angle of the thyroid wings. This anterior insertion occurs on two closely adjacent points. The anterior commissure, the thyroarytenoid ligament, is composed by elastic fibers that support the medial or free margin of the focal fold. Two focal folds also mark a division of the larynx into an upper and lower compartment. This division reflects of development of the larynx from the several embryonal components called branchial arches. The supraglottic portion differs from the one beneath the vocal folds. In the upper portion is innervated sensorily by the superior laryngeal nerve, and the lower infraglottic portion by the recurrent laryngeal nerve. The lymphatic from the upper portion drain in an upward lateral direction, while the lower lymphatic drain in the lateral downward direction. Next is nasal cavity. In oral sound, most air is expelled via the oral cavity. Typically, the velum is raised at the back of the mouth to block the passage of air into the nasal cavity. In the nasal sound, on the other hand, the velum is lowered to allow airflow through the nasal cavity. In English, nasal consonant accompanied by blocking the airflow through the oral cavity. Notice that the movement by your tongue and the lips identical by the A and B example on the 1, 2, 3 images in the PowerPoint. The only difference is the velum is raised in the A example and lowered in the B example. The lateral wall of each nasal cavity mainly consists of maxilla. However, there is deficiency that is compensated for by the perpendicular plate of the palatine bone, the medial pterygoid plate, the labyrinth of ethmoid, and the inferior concha. The paranasal sinuses are connected to the nasal cavity through the small orifices called ostia. Most of these ostia communicate with the nose through the lateral nasal wall via a semilunar depression in it known as the semilunar hiatus. The hiatus is bound laterally by a projection known as the uncinate process. This region is called osteomeatal complex. The floor of nasal cavity, which also the form of the roof of the mouth, is made up by the bones of the hard palate, the horizontal palate of the palatine bone posteriorly, and the palatine process of the maxilla anteriorly. The most anterior part of the nasal cavity is nasal vestibule. Nasal vestibule is enclosed by the cartilages of the nose, lined by the same epithelium of the skin. Within the vestibule, discharges into the typical respiratory epithelium, the lines at the rest of the nasal cavity and the respiratory tract. Inside the nostrils, that vestibule are the nasal hair, which filter the dust and the other matter that are breathed in. The back of the cavity blends via echoanae and into the nasal pharynx.